All right, everyone. I'm going to work through the derivative of arcsine of x. And on your homework this week, you have to work through the derivatives of arccosine and arctangent. So I'm going to demonstrate the process with arcsine. And so we're going to start with this one equation that is kind of everything. I'll just zoom in on it. We're going to start with this equation that if we do the sine of arcsine, we're going to get back x. And so this is kind of the definition of arcsine, is that it's what undoes the sine function, what are called inverses of one another. And so what we need to do is we need to draw a triangle so that when I draw in this blue angle, whatever this blue angle is, the sine of this blue angle is supposed to equal x. Right? That's what I need to draw. And if I zoom out a little bit here, you can see I've set that up. So I've got my blue angle, and all I'm trying to draw is some picture that demonstrates that the sine of the blue stuff is x, or x over 1. So I've written x as x over 1 because that's a ratio. And now I can think about SOHCAHTOA, and I can think about that sine is going to be opposite over hypotenuse. And so that must mean that if I want my opposite over hypotenuse to be x over 1, I need to put the x and the 1 into the triangle this way. And so on your homework, you have to work through the derivatives of arccosine and arctangent. So you might want to go and fill in those triangles for you, but instead of using SOH for sine, you may use cosine, you may use tangent for your pictures. So now I've filled those in, and now I want to find this remaining side. Let's call it A. And so we want to find the remaining side of this triangle. And so now if I use the Pythagorean theorem, I would say a squared plus x squared equals 1 squared. And now I can solve for a. So I subtract x squared from both sides, and I get a squared equals 1 minus x squared. And if I want to solve for a, I need to square root both sides. Square root of 1 minus x squared. So now I'm going to fill that in here. And again, if you're following along with your triangle, maybe you're doing arccosine, maybe you're doing arctangent, go ahead and fill in the third side of your triangle. You may need to use the Pythagorean theorem. You may be adding, you may be subtracting. Just do it really carefully and see what you get. Okay. So now we have a full filled in circle. Sorry, I said circle, I meant triangle. We have a full filled in triangle with our angle. And so now what we're going to do is we're going to go back to our master equation, sine of arcsine of x equals x. And now I'm going to say this is nothing other than a sine of smiley face setup. And so if I want to take the derivative of both sides of this, if I want to take the derivative of both sides, well, if two things are equal, the derivative of those things should still be equal. So if I take the derivative of the left side, it should be the derivative of the right side. Okay, that's fun. What's the derivative of the right side? Well, the derivative of the right side is just 1. And now the derivative of the left side, well, this is our wonderful chain rule. So the derivative of sine of anything will be cosine of that thing times the derivative of that thing. And so what do we have? Well, if we had smiley face, it would go something like that. We have cosine of smiley face times the derivative of smiley face. And in this case, what is our smiley face? Well, I'm just going to literally copy paste it. Our smiley face is arcsine. So I'm going to put that in both of these positions. Look how fun it is to copy and paste. And now I notice this is what I'm trying to find. I'm trying to find the derivative of arcsine of x. And so this is my mystery thing. And so what I can do is I can solve for it. And I can say this thing I'm solving for, the derivative of arcsine of x, that must be 1 over, right? I must divide both sides by this other factor. So I must divide both sides by this. So if I do that, I'm going to get 1 over cosine of arcsine of x. And so this could be an answer. It might be a way that we can say, okay, we're kind of done. But I want us to go a little bit more. and simplify this answer to something more reasonable. And I want to go back to kind of this blue stuff. Remember, our arc sine of x was an angle, right? Remember, it's this angle here in our picture. And so every time I see this angle, I'm going to highlight it in blue. Here's our angle, here's our angle, here's our angle, here's our angle. And I want to focus at the very, very end when you have that 1 over cosine of arcsine. Well, I need to do cosine of an angle, right? This is just cosine of some angle. And to find the cosine of an angle, well, I can use SOHCAHTOA. And I look at my picture, I say, wait, do I have a triangle that has this blue angle labeled? Yeah, I do, it's right here. So I have that blue angle labeled. And so now what I can do is I can say, I bet I can do cosine of the blue angle. It should be, so SOHCAHTOA should be adjacent over hypotenuse. So this is my adjacent, this is my hypotenuse. And so it should be the square root of 1 minus x squared. And so now I put everything together. I can now put that in. What was 1, this whole denominator down here, cosine of arcsine of x, well, I'm going to copy paste it, right? And what did I just discover that cosine of the blue angle was? Well, that whole denominator is equal to the square root of 1 minus x squared. And so this is our derivative for the arcsine of x. And so if you want to get practice, what I might recommend doing is just try to reproduce this whole thing, following all the steps I did for arcsine, and see what parts that make sense. You can comment on this video, you can send me an email, I'll get all those things. But then I also want you to go through and do the same thing for arc cosine and arc tangent. And so I want you to draw pictures. I want you to work out what the derivative of arc cosine x is. And I also want you to find the derivative of arc tangent. Right, and I'll just tell you what the answers are, right? You can just Google to find these derivative formulas. But the answer is not what's important here. What's more important is the method. And so these are what the rules look like. And just to give you one little hint that you might need for the arctangent problem is that the derivative of tangent of x, well, I'll do tangent of, yeah, I'll just say the derivative of tangent is going to be secant squared. And so you may need to, in your triangle, you may need to use the formula for secant, which in our SOHCAHTOA, secant is the reciprocal of cosine. And so secant is actually going to be the hypotenuse over the adjacent. So this problem is challenging, and I'm happy to help. Kind of send your work kind of halfway through. I can offer comments. We can talk about this in office hours. But once you kind of do these problems and really see how everything fits together, it'll all make hopefully a lot more sense. So thanks for sticking through till the end. Have a great day. Bye.